Bismillahirrahmanirrahim. Assalamu alaikum. Today we will discuss about PIC IO ports and their programming. That how these ports are used and how we program it. In PIC 18, we will discuss IO ports and their programming and their bit programming manipulations. IO port programming in PIC 18. So PIC 18 has many ports. It depends on the family of members. It also depends on the number of pins on the chip. Each port can be configured as a input or output, like bidirectional ports. So each port has some other functions, like in timers, in clocks, ADC, interrupts, and serial communication. So there are different types of ports mentioned in 4 points. So some ports have 8-bit while other have not. So IOSFR, special function registers, their IO ports. Each port has 3 registers for its operation, like tries registers, their data direction registers. So if the corresponding bit is 0, then output what will be? If their corresponding bit is 1, then what will be its output input? Port registers, these reads the level on the pin of the devices. So latch registers, it's output latches. Latches are like a digital in the form of 0 1 data will be stored in it. The data latch register is useful for ready modify for write operation, read operations on the value of input pins which are driving. In this example, what's the example says that write a test program for a PIC 18 chip to toggle all the bits of port B, port C, and port D. So every 0.25 of second, suppose we assume that 4 megahertz crystal frequency. So there is a solution for your ease purpose. You can also compile on your compiler and then check its result. Is there any corrections? Is there any error? Then you will be modify. IO bit manipulation programming. So IO ports and bit addressability. It's monitoring a single bit, reading a single bit. This topic is from the book of Mazidi of section 4.2. So bit oriented instruction for PIC 18, these are instructions given and their function, like BSF, BCF, BTG, and bit FSC and bit FSS. These are instructions which are used for a bit orientation purpose and its function, like BSF function is bit set file register, and all the functions are given. In another example, what's say that a LED is connected to each pin of port D. So in program you see that we are using port D. So write a program to turn on each LED from pin D0 to D4. So it's a program of LED blinking, different time delay depends upon user, and LED blink I think so 4 times. So you will be check it on your compiler. There is another example in which programmer what you want say, it says that create a square wave of 50% duty cycle on the bit 0 of C. The solution is given, and after compiling you see that how many bits are used. Example 4.3 is it's another way of solution. You see that how can is it work. Example 4, write a program to perform the following. Which one? Keep monitoring the RB2 bit until it become high. When RB2 becomes high, so write value of 45H to port C and send a high to low pulse of OD3. Its solution is given for your comfort, and you will check how it will work. So example 4.5, in example this electronic circuit of LED blinking, and I think so it's use of 555 timer or a simple circuit in which LED blinking by using a push button S1 and R1 register is only used for a current limiting register, and R2 is also used for bypass register. So in example say that bit RB3 is an input and represent the condition of a door alarm. So whenever it goes low, send high to low pulses of RC5. You see where's RC5 in figure, and then buzzer will be on. It's there's a solution of this program. So in another example, we will read a single bit. How a switch is connected to a pin RB0 and a LED to pin RB7. So write a program to read the status of switch and send it to the LED. So there's program of this example from right side. There is another instructions and the functions mentioned that what's the function if there's any program in which these instructions used. So you may know that what their function will be performed. So from next topic, it's topics from chapter number 5 of this book, and our topic is arithmetic and logic instruction, which we will use for program purpose. So arithmetic instructions, these are unsigned number are defined as data in which all the bits are used to represent data. So no bits are set aside for a negative or positive sign. Addition of unsigned number, like there are some mnemonics are used like add LWK, add WF. These are some formats are given. So what will be happen of these flags registers? In this example, you see that by adding two number. So first step is that store the sum in file reg, which location is like 6 and 7, where the location 6 should have the lower byte. In this example, you see that how it will work and how data will be shipped from one register to, and how this process will be obtained. BCD number system, binary coded decimal number system. So we use a digit 0 to 9 in every decimal system. Binary coded decimal system, these are unpacked BCD, like 4 bits is just used. So it require only 1 byte. In BCD, packed data is used, like a single byte has 2 BCD numbers. So it is efficient for storing data. In right side, you see that how BCD conversion will be used. BCD is like a result. If the result is from like undefined number or invalid number, then we add something. So you also study this topic in digital logic design. So to correct the problem, we should add the number 6 for BCD correction. There are some decimal adjustment reg register. It's work only with WREG. So add 6 at the lower or higher nibble if needed, or undefined states. Undefined now. I say that these are the states in which not mentioned in BCD coding. So after execution, if the little lower nibble is greater than 9, yes. Or if decrement is equal to 1 DC, then add this number like 0110, which is equivalent to 6 to the lower nibble if the upper nibble is greater than 9, or if like carry is equal to 1, and then add to the this format this the number 0110 to the upper nibble. So it doesn't require the use of arithmetic instructions prior to the do execution. So subtraction of unsigned number. Subtractor circuit is used some in not a good way. Why? So PIC perform the 2's complement, then use the adder circuit to the result. So for subtractor, we will perform 2's complement circuit. So take one clock cycle, then there are 4 sub instructions given that. So its result may be negative. For this purpose, negative value will be 1 and carry value also 1. So this will be performed by using 2's complement. Examples given that if you want to subtract this number, then how it will work in like digital system, but we are not performing like this type, so we will perform by using PIC, and these are some assembly language are given. In another example, subtract like 4c minus 6e. For this purpose, in left side you see that equivalent of 4 and c, then minus from this and this. For this purpose, their flags are given. So for that purpose, we will perform by using right side, their solution is given. Signed number concepts and their arithmetic operations, like the most significant bit MSB is set aside for the signs like 0 or minus. For reset, 7 bits are used for the magnitude. So to convert any 7-bit positive number to negative use, then for this purpose we will perform this function by using 2's complement. So we have 128 negative numbers and 127 positive numbers. Overflow problem in signed number operations, and overflow occurs when the result of an operation is too large. So for the register, overflow flag indicates whether the result is valid or not. There are some conditions are given. If this value is equal to 1, then result is anomalous, and if 0 flags set, then there are some carry changing. You also see that in examples. In left side there is a decimal numbers, and in right side there is binary equivalent, and their result, and there are some carry flags mentioned there. So logic and compare instruction, these are widely used instructions. These are some instructions given like exclusive or and many more are given some instructions. So it will be effect on 0 flag and negative flags. There is another instructions, complement instructions. Their syntax is COMF, like file register, then their destination. It takes one's complement of file register, then it effect only 0 and negative flag. Like a negative flag reg file registers, it takes 2's complement of a file register, then effect the flags. The example is given below, and there is some another compare instruction in which some formats are used, and their instructions are given at how this instruction will work. There is a flow chart of these instructions, so there is no need for this. It's only for your understanding purpose. There is another flow chart for a CPF sequence. This is also a flow chart of CPF SLT solution. So this example, write a code to determine if the port data port B contains the value 99H. If so, write letter Y, like Y to port C, otherwise make port C is equal to N. There is a program in which it says that port B which contains the value of 99H, then you write it, overwrite it, and otherwise in case you will write some value mentioned in this program. By continuing this lecture, this topics from chapter 6 of this Mazidi book, and we will discuss like switching, table processing, and macros of and their modulings. Objective of this chapter is we will discuss different addressing modes of PIC 18 microcontroller, their contrast and their comparison of addressing modes, codes of PIC 18 instructions, that how it will manipulate, and their data in ROM spacing, and discussing of macros and modules, its advantages, and how to access the entire 4 KB of RAM. And also we will discuss a list of addresses of all 16 banks of PIC 18, and also their switching of PIC 18. Our outlines are like direct and immediate and direct addressing modes, which we will discuss in previous lectures, register indirect addressing mode, and lookup tables and their processing, bit addressability of data RAM, and bank switching, and checksum and ASCII subroutines and their some modules. So first one is intro, in which data could be like in register, like it may be in memory, or also in their some immediate values. So PIC 18 provides 4 addressing modes which are listed First one is immediate, second one is direct, third one is register indirect, and fourth one is index strong. So this topic from section 6.1, in which immediate and direct addressing mode. So in immediate addressing mode, the operands come after the opcode, like mentioned in this example. So in direct addressing mode, the operand data is in RAM location whose address is known and given as a part of the instruction. Like these are mentioned in this example and also shown in your micro C, their programming interface. Direct addressing, there are some use mnemonics move ff and move wf, and there are some syntaxes given and how it will be work. Like actually these are topics we are discussing in some previous lectures. You can also review from there in this on previous lectures briefly. So we are totally touch in this lectures of this topics only for go through immediate and direct addressing mode. What is different between them? There's an increment and thus what will be its default destination. So difference between these are also some assignment task mentioned in addressing and direct addressing lectures. So these are also from these are some copy slide, like SFR register and their addresses can be accessed by their name, their addresses, and which one the way is easy to remember. So SFR register and their addresses, like remember SFR register, special function register addresses is started at FAATH and the last location has this address is triple FH. So there is some important note in .is file. You will see that the SFR names are replaced with their addresses. So WREC register is one of the SFR register and has addresses of FE8H. There's another topic, section 6.2, in which register indirect addressing mode and used to pointer the direct data from RAM location. So there are 12-bit register used from 0 to triple FH. So there are some mnemonics are given. Each register associated with this instruction, their syntax is also given, and it contains its 2 cycle for their execution. Advantages of registers, like it makes accessing data dynamically. Looping is possible to increment the addresses, not possible in direct addressing mode. Their example is given below. There is another example in which programmer said that write a program to copy the value of 55H into RAM location. Location is that 40H to 45H. So how? By using direct addressing mode, register indirect addressing mode, and by using loop. So there are 3 tasks. First one is like direct addressing mode. The solution is given in right side, and the second one is register addressing mode, and the solution is given this left side, and the third one is like by using loop, and their looping sequence is performed. So auto increment option for FSR. Normally increment can cause problems, like since it increments 8 bits. So auto increments and auto decrements solve the problem. Like using this example, you see that so in this section we will discuss input and outputs units and their ports, and there's some interfacing how. In overview, you see that input devices, there are some controller of IO, input output controllers, and there's some memories like a system memory in which IO devices and their controller memory is used, buses are used for data traveling and transferring purpose. So input output problems, there are some peripherals like various method of operation in which some logical operations within the processor to control a different devices in. So data transfer rates of peripheral is often much lower, because these are serial ports communication. So data transferring from these devices or peripherals in serial form, so it will be much slow as compared to another communication way. So peripherals uses a different data formats, their sizing, their word length is different, and their data transfer rate is also different. In this blocks you see that IO modules, there are some controlling lines, there are some data lines, there are some addresses line. Different types of buses are used which are connected with the IO modules, and there are some peripheral devices which are connected with these modules. So there are main two major functions, which one interfacing of CPU and thereby in memory, and interface to one or more peripherals. External devices provides exchanging of data. It attached to the computer by using a IO module, and then these external modules and devices are connected, and then peripheral devices are connected to IO modules. There are main three categories like human readable, machine readable, and communication readable. Human readable which are for computer user purpose, like video display, LCD, printer, LED. Machine readable like hard drive, and their magical tapes like sensors, and communications different devices which are communicate with each other either internally or externally. So there is another block diagram in which we will easily understand that control logic, the main function is that controlling the functions of data signals from input to output modules, interfacing purpose, and then buffering between this controller and the modules and between buses. So like keyboard or monitor is common example. There are some international reference alphabets. We know that. So basic units of exchange is characters, like codes, binary codes, and different characters. So characters are two types. First one is printable, like alphabets, numeric, special characters that can be printed on paper or display on a screen. So control example is like carriage returns. Other control characteristics are concerned with communication procedures, like most common means of computer user interactions, like user provides input through keyboards. Keyboards it's used for input purpose. So when the user press a key, it generates an electronic signal that is interpreted by the transducer in the keyboard and translated into the bit pattern of corresponding IRA code, like International Reference Alphabet Code. So this pattern is transmitted to the IO module in the computer monitor output. On output, like RA codes characteristics are transmitted to an external devices from the IO module. So the transducers interprets the codes and sends the required electronic signal to the output devices for displaying or processing purpose. So the major functions for an IO modules fall in the following categories, like controlling and timing purpose, processor communication, device communication, data buffering, and error detection. So this is the block diagram in which previous all blocks are mentioned at, like data registers, control registers. These are controlled by using data lines. External devices interfacing, like their data, their status, their controlling. External devices interfacing their logics and IO logics, and their IO logics controlling by control lines, and also communicate by using address lines. IO modules decisions. IO modules may hide the details of timing, formats, and the electromechanism of external devices, so that the processor can function in terms of a simple read and write commands, and possibly open and close file commands. So IO channel or IO processor and IO module that take on most of the detail processing burdens, like presenting a high level interface to the processor like mainframe. So IO controller or device controller, an IO module that is quite primitive and requires detailed controlling. So input output techniques, these are three techniques for IO operations, like program IO, data exchange, processor and IO modules. Processor executes a program, so processor also issues a commands for the execution purpose. Also the processor is faster than the IO modules, that is wasteful of processor time. So interrupt driven IOs, first one is program IOs, second one is interrupt driven IO. Processor issues and IO commands, continues to execute other instructions and is interrupted by IO modules when the latter is completed. The third one is DMA, direct memory access. The IO module and main memory exchange data directly without process involvement. There is a table in which all techniques are listed below. So IO commands, four types of IO commands. First one is control commands, test command, read command and write command, and their function is given below, that how these commands are work. IO mapping, IO addressing and their memories. Memory map IOs like devices and memory shares and address space. So IO looks just like a memory reader, right? So isolated IO, separate address spaces, need IO or memory select lines. Interrupt driven IOs, different IOs, like a problem is a program with their interruptions driven IOs. There are some modules types are listed, and you can also read it. There's some interrupt processing, like in hardware interruption and software interruption, what will be difference, and there are some difference which will be mentioned in these blocks. That is some interruption will occur in processing, so how hardware work and how software will be work. Decision issues. Two decision issues arises in implementing interrupt IO. The first one is IO modules. Does the processor determines which device issues the interrupt, and the second one, the processor decide which one the process will be executed. Device identification. Four general categories of techniques are used commonly. First one is multiple interrupt lines. Second one is software pool. The third one is daisy chain, like hardware pool, and the fourth one is bus attribution vectors. There are some introductions mentioned there, so you will be read it. Like the drawbacks of program and interrupt driven IOs. Both forms of IO suffer from the two inherent drawbacks. The first one is the IO transfer rate is limited by the speed with which the processor can test and service a device. The second one, the processor is tied up in managing an IO transfer number of instructions but must be executed for each IO transfer. So when a large volume of data are to be moved from different techniques, it will be informed by using DMA, direct memory access. So what is direct memory access? It's an additional modules of hardware on buses capable of taking over control of the system from the processor. It needs to do with transfer data from memory over system bus. So DMA module must use the buses only when the processor doesn't need it, or it must force the processor to suspend operation temporarily. There is a block diagram of DMA, how it will work, and data how will be controlled, how addresses line, and how their control logic will be operated. DMA transfer their cycling. How? DMA controller takes over a bus of cycles. It transfer of one word of data, so no interruptions. Then CPU doesn't switch contexts like pauses of one bus cycle, so CPU suspended just before it assesses buses. DMA controller transfers 16-bit words to memory using cycle stealing. Words are assembled from a device that transmit characters at a rate of 2400 characters per second. So the CPU fetching instruction at even average rate of 1 million instruction per second. By how much will CPU will be slowed down? By using of DMA transfer. So how evaluation of IO functions? As computer system has evolved, there has been a pattern of increasing complexity and sophistications of individual components. There are some key points. The CPU directly controls peripheral devices. A controller or IO modules is added. The CPU uses program IO without interrupt. So same configuration as in step 2 is used, but no interrupts are employed. The CPU will not spend time waiting for an IO operation to be performed, thus increasing efficiency. So there are some another points. You will be read it for your own purpose. The type of interfaces: parallel interface, serial interface. In parallel interfacing, data communication is fast simultaneously, and for this purpose, parallel peripherals devices are used for parallel interfacing. Multiple bits are transferred in serial communication, transmit data one by one. So for high speed serial interface, a parallel interface are becoming less common. So there is a block diagram in parallel and serial, how data will be communicate or transfer from buffer to system or system to peripheral devices. There are some examples of peripheral devices. USB, Universal Serial Bus, widely used for peripheral connections. Default interface for slow speed devices, commonly used high speed IOs. Its version are USB 1.0, 2.0, 3.0, 3.1. What will be difference? Is a difference of speed, speed rates. For copying purpose, for moving purpose, if their version is changed, and then the speed will be vary, as mentioned in this slide. Firewire serial bus. You see right top there some pics of this. These are SCI to be used, smaller system like personal computer, PCs, workstation and server. For this purpose these buses are used cables. So their objective is to demands of higher IO rates while avoiding the bulky expensive IO channels. There are some standards of these buses like IEEE standards, and there are some standards are shown. So these are fibers of 1022 and interconnected by using bridges. Also provide automatic configurations, so no termination, and the system automatically perform configuration to assign the addresses. SCSI, small computer system interface. You see right bottom, it's a common standard for the connecting peripheral devices to small and medium sized computers. It has high loss popularity to USB and Firewire in the smaller system. So it has high speed version remain popular for mass memory support and on enterprise system. So physical organization is a shared bus which can be support up to 16 or 32 devices depending on the generation of the standard. So this bus provide for parallel transmission rather than serial, with the bus width of 16 bits on earlier generation and 32 bits on a later generation. So speeds range from 5 megabits per second on the original SCI 1 and specification of 160 Mbps on the SCI 3U3 version. This one is Thunderbolt. You see it in this picture. These are most recent and fastest peripheral connection technology become available in general purpose uses. It developed by Intel with collaboration from Apple's. It provides up 10 Gbps throughput in each direction and up to 10 watts of power to connected peripherals. The technology combines data, video, audio and power into a single high-speed connections for peripherals such as hard drives, RAID arrays, video capture boxes and network interfacing. This one is InfiniBands. These are IO specification aimed at the high-end server market, used for networking purpose. Its first version in early 2001 made by IBM. There's some standard and there are some specifications are given, become more popular due to storage areas for networking purpose, for enabling servers, remote storage and switching purpose, and it's connect up to 64,000 servers at a time. PCI Express. It's a high-speed busy system for connecting peripherals for a wide variety of types and speeds. SATA, Serial Advanced Technology Attachment. Its interface of a disk storage system provides data rates of up to 6 Gbps. with a maximum per devices of 300 Mbps. So it widely used in desktop computer and in industrial and embedded applications. Ethernet, a predominant wire networking technology. It's evolved rates of 100 Gbps and a distance from few meters to tens kilometers become more essential for supporting personal computer, workstation, server, and massive storage devices. And experimental, its bus-based 3 Mbps system has moved up to bus-based or switch-based system. Its data rates periodically increases in order to magnitude. So it works as a central switch for other devices, and Ethernet system are currently available at speed up to 100 Gbps. Wi-Fi, commonly used. It's a predominant wireless internet access technology. It connects computer, tablets, mobiles, camera, many more things, as you know. So in enterprises, it's become an essential means of enhancing worker productivity. Public host and expand dramatically to provide free internet access. Also, a technology of antennas, wireless transmission techniques, and much more. Its IEEE standard is 802.11. Its current version is 802.11 AC 2014 with a maximum data rate of 3.2 Gbps. So now we will discuss internal memories of processor and how internal memories will work. In this figure, you see that a cell, it's a unit of register in which data will be stored, and how it will be write, and how it will be select, how data will be controlled, and how data will be read, how data will be removed, or how data will be sensed is there any data in the cell. So there are different types of memories, like RAM, ROM, EPROM, PROM, and flash memories, and their categories and how it will work and how data will be stored in this, and which type of memories like volatile, non-volatile, as we know from first day. Random access memory, RAM technologies, two types like SRAM and DRAM, static RAM and dynamic RAM, made with cells. Dynamic RAM made with cells that store data by using a charges of capacitors. That capacitor charge stores, and then correspondingly data will be stored. So capacitor charge by using a binary number 0 or 1, like capacitor is charged, the data will be 1. In case of discharge, data will be 0. So it requires periodically charging and discharging. So dynamically the storing of charges leak away. For this purpose, data will be lost. Dynamic RAM, there is example mentioned that bit stored in charge capacitor. In absence of charges, it represents 1 or 0, and there is some simply constructions are shown that address line, it will be controlled by using transistor, and in case transistor will be on, then charge will be stored in capacitor. Its mean data will be stored, and there is some limitation mentioned in left side. There is smaller per bits, expensive, less expensive, and slower, and there is some essential for analoging purpose. DRAM, operations line like active like bit reading and writing purpose. Transistor switch close, its mean current flow, and for open purpose current doesn't flow. Analog devices, capacitor can store charge like values within a range or threshold range, so value will be used to interpret it. DRAM, for writing purpose, voltage to bit line like bit like 0 or 1, so high for 1 and low for 0. For reading purpose, address line will be selected, transistor will be on, charge will be flow from capacitor by using bit line of sense to amplifier. Then it will compare the value, determine 1 or 0, then capacitor charge will be restored. So static RAM, and it's a digital devices that use the same logical element used in the processor. So binary values are stored using traditional flip-flop logic gates. Configuration will hold its data as long as power is applied to it. SRAM configuration is mentioned there, but there's some extra feature in SRAM as compared to DRAM. So SRAM versus DRAM, in which all features are mentioned there. So you will read it and then decide which one is more effective and more good, like SRAM or DRAM. So ROM, read-only memories. contains a permanent pattern of data cannot be changed. One time data will be stored, it will not be removed, it will not be write. You can read it. So there are some advantages. Data only one time, I read it. So PROM, programmable ROM, like less expensive, non-volatile. So data can be again its own programmable. You can rewrite it by using a process of electrically. So there is a comparison of both EPROM, double EPROM. EPROM stands for electrical programmable read-only memory. Double EPROM, electrical erasable programmable read-only memory, and flash memory. There are some comparison of three ones, and you see that which one is more better. Definitely flash memories. So there's some diagram in which memory, there are some parts of memories and how data will be stored, and which part, and it's like plates of a hard drive in which you see there are different banks and their grouping, their memory bank, and there's some locations are mentioned. Error corrections, how heart failures, like physically defected memory cells are affected, like the charge may be not stored. So there's some harassment, manufacturing defects, or some software errors like random or non-destructive events alters. No permanent damages to memory, and it caused by the power supplies problems. Advanced DRAM organizations, one of the most critical system bottlenecks when using high performance processors is the interface of the main internal memories. So traditional DRAM chip is constrained both by its internal architecture and by its interface to the processor memory bus. So a number of enhancements to the basic DRAM architecture have been explored. Synchronous DRAM, SDRAMs, there's some mentions, some things, exchanging data processor by synchronizing by clock signals by running full speeds. Also it's a master issue of instructions. DRAM sets of clock cycles. So far in the mean times the task, and there are some tasking safety and the processing issues. So double data rate, DDR, DDR SDRAM, developed by JEDEC, Solid State Technology Association, Electronic Industries Alliance, Semiconductor Engineering Standardized Body. So numerous companies make DDR chips which are widely used in the desktop computer and servers. DDR achieves high data rates in three ways. First, the data transfer is synchronized to both the rising and the falling edge of the clock rather than the rising edge. The second one is DDR uses high clock rate on the bus to increase the transfer rate. The third one is buffering scheme is used. So flash memories used both for internal memory and external memories application. First introduced in the mid of 1980s, is intermediate between EPROM and double EPROM in both cost and functionality. Uses our electrical erasing technology like double EPROM. It is possible to erase just blocks of memory rather than the entire chips. So uses only a transistor per bits, so it achieves a high density of double EPROM. Summaries of this overall lecture is that semiconductor main memories, their organization, DRAM, SRAMs, types of ROMs, their error corrections, DDR, DRAM, synchronous DRAM, DDR SDRAMs. So in memory unit, the next one topic is cache memory. There is some memory hierarchy, like design constraints of computer memory can be summed by like three questions: how much and how fast and how expensive. That how much memory will require, and how fast it will be communicate, and how much it will be expensive. So there is a little trade-off like capacities, like faster access time, greater. There are some parameters are mentioned. So the memory for a single memory components technology. For this purpose, you see the some diagram in which you see that like disk, like magnetic disk, hard drive, its size is larger, and but its speed is slow. So in middle memories like RAM, ROM, DROM, SD-ROM, their speed is much more than hard drive. or magnetic disk, but size is much smaller than hard drive. So the third one is cache memory, like static RAM, SRAM. Their speed is much more than hard drive and memories like RAM ROMs, and their size is much smaller than RAM ROMs. And the last one is like processor memories, CPU memories. These are registers. It's the most faster, and their size is too much small. So there are some common predictions. Their patterns, two patterns like temporal locality. If a location is referred, it is likely to be referenced against the near future. So spatially locality is that if a location is referenced, it is likely that location near, but it will be referred in the nearer future. Locality reference, you see that there are some examples like loops, subroutines, and arrays. So the organizing of data across hierarchy, such as that the percentage of accessing of each successive lower level is substantially less than that of level above. Cache memory. Cache exploits both types of predictability, like exploit temporary localities by remembering the contents of recently accessed location. So exploit spatially locality by fetching blocks of data around recent accessed location. There's another important thing, that how can we calculate the cache and main memory. The formula is given on your screen, so you can calculate by using their parameters. N and K blocks are mentioned below. Another thing is that cache operations tags. As number of blocks is more than the number of lines, so cache lines can be dedicated to blocks. Therefore, cache includes tags to identify which blocks of main memory is in each cache slot. So the tag is usually a portion of main memory addresses. So there are some concepts related to cache hit and cache miss. The hit ratio, the fraction of all memory accesses that are found in the faster memories like caches. Cache operations like CPU request contents of memory location, so it check cache for this data purpose. If presents get from the cache, it will be cache hit. If not present, it will be cache miss. So there are two level for accessing time. The level 1, it contains 1000 words, and level 2 contain 100,000 words. And how much time will be required? 0.001 second and 0.1 second, sorry, microsecond. And there are some example given below, that how cache memory level will be work. So there are some summarized cache addresses, like these are logically, physically, and their sizing, their mapping functions, and their replacing algorithm. Cache size are small enough, but large, it will be large enough, and their mapping is like directly, associatively, and set associative. Directly by using simplest technique, associative like in blocks, in the form of blocks for cache purpose, and set associative, it's a exhibit like strength of both direct and associative purpose. Direct mapping, like each block of main memory maps to only one cache line. If a block is in cache, it must be in one specific place. So the cache memory is divided into blocks or lines. Data is copied and from the cache on line at a time. In this example, you see that how can we calculate the cache and their size and their bits and their memory by using given formula. There's another example in which how many bits are in the tags, line, and offset fields, which are solved and then shown below. Direct mappings, like a simple, it will be inexpensive, fixed location for the given blocks. So if a program accesses two blocks that map to the same line repeatedly, cache miss is very high. Assertive mapping, in which mentioned on previous slides, that you also read it, and in associative mapping, tags and their word fields are how it will be unique, identify different main blocks. So assertive mapping, their address length is by using s plus w bits, and their number of addresses by using given formulas. Their block size can be found by 2 power w. So also their number lines can be undetermined, and the size of the tag is by using s bits. Set associative mapping, it's also 2 lines per set, and there is example in which how there are 3 types. So one by one, when if you know about their formulas, then you can calculate their associative, general, and direct memory sizing. This is our second last topic, like operating system, their sports, and how operating system will be work. The objective of this lecture is that operating system is a program that control execution of application program. So operating system act as interface between the user of computers and the computer hardware. So their objectives are like convenience and their efficiency. The most important the system is like operating system is system program like window, which will be used for the operating of hardwares and their interfacing. There's some block diagrams of computer hardware and software structures, like how operating system will communicate with like systems like memories, main memory, how it will connect with the hardware, softwares, and how all system will be work. All things is mentioned in this block diagram, so it is important for understanding of operating system and how it will be work. So these blocks are explained one by one. Operating system services like program creations like editor, debuggers, program executions like instruction, data loading, memory, IO devices, assessing of IO devices, controlling of files, system assessing like error detections, accountings. There are some facts. There's important things for operating system services. There are some examples that how it's for assignment purpose for your practice, that you will be work by using that mentioned that by using 2 addressing instructions. This equation you will be solve it. So operating system as a resource manager, it's responsible for managing every resources, also some functions, their softwares, their operations frequently, and how it will be operate. There is another figure in which operating system how it will be resource the manager, that by using controller like IO controllers, program controllers, processor, and different media. So operating systems are 2 types like interactive systems. These are user programmer interface directly with the computer, like execution of job, like perform system functions, like it depends on the nature of application which we want to communicate. Batch system, like opposite of interactive, the user program is batched together with programs from other user and submitted by computer operators. In early systems like 1940s and 1950s, operating systems are different and their working is different. Their scheduling, there's another important thing is processor scheduling, and how their processor will be work, and this could be result for wasting of computer timing and their processing speed. So setup times in which how data will be load to the compiler, then source program, and then go to memory, then save the compile program, and then give us output. So simple batch system like resident monitor program, it uses submit jobs to operators batch jobs, monitor control sequence of events to process batches. So when one job is finished, control returns to the monitor which reads the next job. Desirable hardware features, these are memory protections. User programs must not be altered to memory or containing. So the processor hardware should detect the error and transfer control to the monitor. The monitor aborts the jobs, prints an error message, and then load to the next job. The timer, it's used to prevent a job from monopolizing the system. If the timer expires, an interrupt occur and control return to the monitor, like privileging the instructions Also, IO instructions are privileged, so the monitor retains controller of all IO devices. Interrupts. It gives the operating system more flexibility in relinquishing controls and regaining controls from user program. So how process? A program is in execution, its name as process, like process control block PCB. These blocks are mentioned in right side and one by one. These are identifier, state, priorities, then program counter, then memory pointer, then context data, then IO status information, then last one is account instructions. This is a 5-state process models. First one is from left to right, a new program, then it will be admit and ready for processing. It may be blocks, it may be dispatch for running purpose. At last it will be released. In case of any timeout, it will be again reprocessed, or it will be maybe in QE form. So there are types of scheduling like long term scheduling, medium scheduling, short terms, and I scheduling. And their scheduling types are mentioned. That's what's its scheduling and how it will be work. Long scheduling, in which programs are submitted for processing purpose. Then once time it's submitted, then its job will be processed for a short scheduling purpose. Medium scheduling purpose, it's also known as dispatcher. It's execute frequently and makes the fine-grained decision for which job to be executed. Medium term, it's parts of swapping function. Swapping in decision is based on the need of the manage of degree of multi-programming. So swapping in decision will consider the memory requirement of the swap out process. So there is another some question for your practice purpose, in which you see that program of some timer, that how it will be work program in the form of C. Yes, it's your you will you also practice in micro C compiler, and the second one is another assembly language task. So it will be a simple easy task. It's you can do it. So what is swapping? Long term query for process store in a disk. Process swap in as space become available. As a process completes, it is moved out of main memories. So like these are two, the swap out and swap in.